So this video is on the cube root function. Y is equal to a times the cube root of x minus h plus k. This is the inverse of the x cubed, the cubic equation. So right here I have the parent equation, y is equal to the cube root of x, or x is equal to y cubed. Again, you'll see that it's the inverse of y equal x cubed, where you switch your x and your y, your inputs and your outputs, in order to get an inverse. Now, we're going to be looking at it in this y equal form, but I did write the general equation of this in x equal form, a times y minus k cubed plus h. So when the y has a variable with it, that's going to affect your up-down movement. So this is going to be your k, because it's always your k that goes here. And then the plus h is going to actually be your x. But again, we're going to look at it in this form here, y equal. Now, I'm going to graph just my basic cube root. Okay, so I'm just going to be plotting cube roots of numbers. So the first one I'm going to do, and I'm going to do this in orange, and this is going to be my inflection point. So I'm going to take the cube root of 0, which is 0. Now I'll do the rest of it in, let's say, purple. So from here, I'm going to go out 1. Okay, so I'm going to take the cube root of 1, and the cube root of 1 is 1. When I go out 2, the cube root of 2 is not nice, cube root of 3, all the way until finally I get to the cube root of 8. That's going to be the next nice cube root. So the cube root of 8 is 2. The next one, I go out to 27, and the cube root of 27 would be 3. Okay, now going in the negative direction. When I take the cube root of a negative, I get a negative. So the cube root of a negative 1 is negative 1. And I'm going to go out to a negative 8, and the cube root of negative 8 is a negative 2. And this is going to be our graph. So when we're graphing this, this is going to look like half of, well, it's going to look like a square root graph that opens left and down. And then once it hits this point of inflection, it's going to change, and it's going to look like a regular square root graph in terms of its general shape. It's not perfectly the same, but in terms of its general shape. And that is your cube root function. Now, I'm going to be doing one that has no stretch and just is moved. So I'm going to get my inflection point by looking here. So the cube root of x plus 2, this part here, what makes this 0 is a negative 2, comma, negative 3. So that is going to be our inflection point. So I'm going to be doing a negative 2, comma, negative 3. That's going to be in my inflection point. And again, I'll do that one in orange, just so you can see where that point is. That's the one I'm always going off of. So I'm going to go negative 2, negative 3. That's my inflection point. Now from there, I'm just going to do basic cube root. So I'm going to go out 1. Cube root of 1 is 1. I'm going to go out the next amount, which was going to be 8. So I'm going to go out 8. So that's 2, 4, 6, 8. And the cube root of 8 is 2. Now I'm going to do the same thing from this inflection point going in the negative direction. So the cube root of negative 1 is negative 1. I'm going to go out 8 away to the left. 1, 2, hold on, let me see. 2, 4, 6, 8. So the cube root of a negative 8 is negative 2. And I'm going to draw my graph. So again, it is like half of a square root that opens down and left, and then it changes to half of a square root that opens up and right. And that is your graph. Now let's try one with a stretch and being transformed. So let's say we have y is equal to 2 times the cube root of x plus 1 minus 4. So my inflection point is going to be -1, comma, -4. So -1, comma, -4. Okay, so again, I'm going to do that inflection point in orange just so we can see where that is. So I'm going to go to -1, -4. Now for this, I'm just going to move this up a little bit and maybe extend it out a little. Okay, so now what's going to happen is I'm just going to do cube root from this inflection point. But after I take the cube root of my number, I'm going to times it by 2. So it's going to be twice as high. So I'm going to come here to my inflection point. I'm going to go out 1. Cube root of 1 is 1, times it by 2. So I'm going to be up 2 above. So now I'm going to go out 8. 1, 2, 3, 4, 5, 6, 7, 8. The cube root of 8 is 2. And then I'm going to times that by 2. So I'm going to go up 4. 1, 2, 3, 4. Going in the other direction from my inflection point, -1 away. -1 cubed is -1. Sorry, the cube root of -1 is -1. I'm going to times it by 2, -2. I'm going to go out 8. So 2, 4, 6, 8. And the cube root of a -8 is a -3. Sorry, a -2. And I'm going to times it by 2, which is 4. 1, 2, 3, 4. So I went out to -8 away. The cube root of a -8 is a -2, but I'm going to times that height by 2 because of my stretch, so I went down 4. And then here is our graph. And then from here it switches, and there you go. Now, I'm going to do one with a negative in front. And what that's going to do is it's going to make this come here. So it kind of is going this direction. And then this is going to go that direction. Okay, so we're going to try this one. Okay, so we have a -3 times the cube root of x minus 2 plus 1. So my inflection point is going to be +2, +1. So I'm going to go to +2, +1. Sorry. Try one more time. Okay, so we are going to go to 2, 1. That's going to be my inflection point. I'm going to change colors just so you can see that's my inflection point. It's part of my graph. But now I'm going to go out cube root of 1, go out 8. So if I go out 1, cube root of 1 is 1, times it by a -3. So I'm going to go down 1, 2, 3. I'm going to go out 8, 2, 4, 6, 8. And the cube root of 8 is 2, times a -3 is a -6. 1, 2, 3, 4, 5, 6. Now, when I go back to my inflection point, now I'm going -1 away. So the cube root of a -1 is a -1 times a -3. That's going to be a +3. So 1, 2, 3. And I'm going to go -8 away. So 1, 2, here, let me just do this. 2, 4, 6, 8. So the cube root of a -8 is a -2. But when I times that by a -3, I'm going to get a +6. So 2, 4, 6. And then we'll connect it. And you see that it has flipped it from where if it had been kind of at the origin, it would have been flipped across the x-axis. And hopefully that helps you with cube root functions.